Today in Atlanta, this team of elite engineers is embarking on an epic endeavor.
We're already out of whack.
They're racing to build a remarkable new superstructure. The world's most advanced sports stadium.
The scale of this is just gigantic.
Let's float this.
Constructed from more than 24,500 tons of steel and capable of seating up to 75,000 spectators. They're pushing to complete this ambitious geometric structure in time for the new football season.
On these big projects, there's always schedule pressure.
That's what this is all about, schedule.
To build this colossus, the team must battle extreme heights.
Man, it's an adrenaline rush, but ain't nothing that beats it.
And deadly winds.
As you're working in an elevated situation, wind gusts knock you off the iron. It don't matter how long you've been doing this. One mistake can cost you your life.
This super stadium ranks in a league of ambitious new engineering wonders that are bigger, faster, taller, and more advanced than anything ever constructed before. This series charts the inside story of the extraordinary race to build these giants. Atlanta, Georgia, a legendary sporting city of 500,000 people. Home of the 1996 Olympic Games and 2017 Super Bowl finalists, the Atlanta Falcons. To accommodate its growing legion of American football and soccer fans, the city needs a brand new stadium. When complete, this will be one of the most innovative stadiums ever constructed and will eclipse the old Georgia Dome. Soaring more than 300 feet tall and costing £1.2 billion, the brand new Mercedes Benz Stadium will be the most advanced arena in the world.
It's such a unique, truly one-of-a-kind building. This is one of those projects that happens once in a lifetime.
Structural engineer Erlene Hatfield has helped design this boundary-pushing edifice.
So we had a lot of crazy ideas, and that's really what allowed us to push the limits and come up with this iconic building.
It rests on the shoulders of Avery Martin to actually build the stadium.
Part of the dangers of this particular project is nothing is forgiving. Everything's big. Everything has the potential to hurt you.
This is the giant Erlene needs Avery to somehow construct. Arriving through the main entrance, the heart of the new stadium. A vast 270,000-ton concrete bowl will hold 75,000 fans and support the 19,000-ton roof structure. From this huge frame will hang the world's biggest scoreboard, a 360-degree, 62,000-square-foot screen called a halo board. It will play in-game action and be viewable from any position in the stadium. Topping it off, the world's most complex retractable roof. It will be made up of 8 vast steel petals that must open and close within 12 minutes to stop bad weather ruining play. Designing and installing this roof will be the most challenging part of this ambitious build.
This is very, very complicated geometry. Nothing like this is even close to ever having been done before.
Stadiums with retractable roofs have revolutionized sports, giving fans year-round action. But the more complex the roof system, the more there is to go wrong. Montreal's Olympic Stadium, built in 1976, had one of the world's most complicated retractable arena roofs. But it ripped and failed over and over again, even when it was converted to a fixed roof. This is the kind of disaster the builders of Atlanta's new stadium must avoid at all costs.
My God, what did I get myself into?
Building this one-of-a-kind arena involves a series of key stages. First, the team must lay down the 18-acre foundation. Then, workers will build 19 vast reinforced concrete columns. This is all that will eventually support the roof. They must assemble thousands of precast concrete slabs to form its walls and floors. Then they must tie together steel trusses to form the base of the roof and fit the sliding petal panels on top. Inside, they must install 71,000 seats and the 616 sections that make up the giant halo board. Only then will they discover if the roof petals roll smoothly, closing to form a perfect seal.
What scares me the most, that when we go to push the button on the mechanization, that it doesn't all move perfectly.
The team begins building the 120-foot deep foundation and piecing together the concrete slabs to form the stadium bowl. It takes 19 months to assemble the arena shell. They construct the 19 concrete mega-columns around the perimeter of the stadium.
They're gigantic concrete columns. In a typical stadium, you might have 50 or 60 little columns that go all the way around the perimeter. But here, we're trying to reduce the number of columns to create a more open feel, better experience for the spectators.
The mega-columns will support the 15,000-ton roof trusses that are built out over the stadium bowl.
The longest truss spans 720 feet across the bowl from mega column to mega column. So they're quite big.
The roof trusses are so long that they erect these temporary 200-foot high steel towers to hold them up as the team assemble them right out across the bowl. With the trusses in place, Avery now faces his first real challenge. He must transfer the weight of the trusses onto the columns so he can take down the temporary towers.
It's going to be a nightmare.
This process is called the jack down. The big unknown, can the columns take the weight?
It would be like the domino effect. If one of these columns was to break in half, then you'd have every one of them follow suit. It would be catastrophe.
So this is the plan. Avery will use hydraulic jacks, positioned on top of the 4 towers, to lower the roof trusses down slowly onto the columns. The jacks will work in unison to gradually close 4 massive steel hinges at the top of each tower. These hinges will be under extraordinary pressure. As the hinges close, the weight of the 15,000-ton trusses should slowly shift off the temporary towers and onto the concrete columns around the rim of the stadium. Once the weight has been transferred, the team can remove the temporary towers and continue the build.
This is a big major milestone for us. To get where we're at now, it's been a long, hard road.
Time is tight. The stadium must be finished in time to host its first game of football just 9 months from now.
There is a time pressure. I mean, on these big projects, there's always schedule pressure.
Getting the jack down wrong could set the entire project back months.
MC7 G5 trusses over here. Make sure the bolts are loose and take a radio with you.
It's 4 a.m. on the day of the big jack down. Avery's taking no chances and makes sure all bases are covered.
These are all names of individuals that I've got placed on each one of these columns. We're putting people at each location to make sure nothing binds up. Everybody's got to be on the same page. Everybody's got to keep their eyes open at all times.
The stakes are high. Timing is crucial. A sudden shift in weight could cause the hinges to buckle.
As we lower these hinges, everything opens up. So you need to pay attention to where your body is standing. Stay focused on everything you're doing. It don't matter how long you've been doing this. One mistake can cost you your life. Y'all don't mind, let's pray. Father, we come before you this morning. I thank you for this milestone that we've reached. I'm asking you for your guidance, your protection as we jack this roof system down. Amen.
It takes gangs of 5 workers positioned at the top of each 200-foot high tower to operate the jacks. This isn't a job for the faint-hearted.
Well, we gotta stay up here till it's done. That could be 15, 20 hours.
Once this comes down, they will not be able to put it back up. So it's critical that you pay attention, it's critical that you know what you're doing, and it's critical that you have clear communication.
All right, guys, it's time to go. Let's start jacking this thing down. Everybody make sure you get your hands and feet out of the way. Pay attention to the movement.
At the top of Tower 3, iron worker Dave Clacius retracts his jacks 4 inches at a time. Each cycle lowers the trusses by 1 inch.
We'll do it many times. I think about 15 times to get it down.
It's only going to close a ½ inch.
Avery must coordinate the teams at the top of each tower to lower their jacks at exactly the same pace.
How you doing, Henry?
We've been 50 minutes for 1 inch.
Go ahead.
We just need to maintain good coordination between all the towers, and it's just a slow process, slow and steady.
As the trusses drop down, these clever bearings that slide gently transfer the roof's massive weight onto the concrete columns.
This slide bearing is designed to move in and out as we jack this building down. It's going to allow this truss to move and flex.
It takes 8 hours for the team to reach the halfway point of the jack down.
Hey, coming up.
But with 7 inches still to go, they hit trouble.
Boy, we're getting heavy. Yeah, you're getting heavier too yet.
The jacks are overloaded, and the hinges are close to snapping under the enormous weight of the trusses.
Some of the iron workers up on the top of the towers noticed that some of the steel is deforming. So they have stopped to take a look at what's going on.
We're gonna have a long day.
The steel hinges start to bend. If they bend any more than a few millimeters, they could buckle.
The worst case scenario is that the jack would fail and the roof would come down very quickly.
We're not 100% sure exactly what's going on at the moment. There's no telling what could go wrong. So that's why we stop and make a plan to fix it. Where's that other? We've got crews moving and getting ready to start reinforcing on the hinges.
They will try to beef up the hinges by welding on extra thick plates of steel. Each plate is carefully engineered and sent up to the top of the towers. The crew work 24/7 to reinforce all 64 hinge arms with the inch-thick steel armor plates. The next day, they restart the jack down with trepidation.
Everything's going to be monitored and watched as we begin to jack this roof down again. Just one more step in the process of eating this animal. Pay attention to the movement.
The team keep a close eye on the hinges to check they hold up.
We just keep coming down until you see daylight, and then the truss is holding itself.
After an anxious 18 hours, touchdown.
The jack down is complete. It's awesome. It's awesome.
You know, this roof structure is so unique. It's awesome. It feels great.
With the roof trusses now resting on the concrete columns around the edge of the stadium, they can take down the temporary towers. This clears space inside the stadium bowl to erect the stands for the seats, fit out the interior, and build the retractable roof petals.
Major accomplishment. Now the hard work begins.
Over the next 4 months, workers pick up the pace. They piece together the geometric steel and plastic facade to create the stadium's show-stopping exterior. Inside, they install 1,100 tons of ductwork to feed the air conditioning system.
Atlanta is a very hot place. Can't imagine sitting for 3-4 hours inside a stadium without air conditioning.
They feed in 1,600 miles of electrical wiring and 60 miles of pipes to service over 1,500 toilets.
We're here in the middle of the bowl. There's 5 months until opening. It's very exciting. So the towers are gone now. The bowl's opened up a lot. You can start to feel the volume of the space. It's a much different environment.
The stadium is vast. Some fans will be almost 300 feet from the field and could struggle to see the action. So the next challenge is to build the world's biggest scoreboard. Instead of a flat rectangular scoreboard that's hard to see from every seat, they're breaking with tradition. Designing an ingenious scoreboard that stretches 1,100 feet right around the opening of the stadium roof. It will be made up of 1,848 massive flat-screen cabinets, each carefully angled to create the curve. Called a halo board, fans will be able to see this 62,000 square foot scoreboard from any seat in the house.
Now that the towers are out, you can see the curvature of the video halo. You can see the steel trusses that support the video halo. So the scale of this is just gigantic. It's the biggest scoreboard in sports.
But the sheer size of the scoreboard creates a unique problem for Erlene.
If we tried to use traditional flat screen technology for the halo board, it would be twice as heavy as what we have designed for now.
The solution is being developed 1,200 miles away in South Dakota.
We have not been asked to design or manufacture anything like the halo display before.
Toby Pulsher has spent 2 years designing special lightweight screens that will fit together to form the scoreboard.
The definition is similar to what you would see at home. It's a high-definition display, except that you'll be sitting several hundred feet from the actual screen.
To create a high-definition video image the length of 3 football fields, Toby can't use traditional LCD flat-screen technology.
We had to modify our standard way of doing things to fit the requirements in terms of power and weight.
To build this screen, he will use 37 million light-emitting diodes, LEDs, almost halving the weight compared with flat-screen technology.
Essentially, your imagination is the only thing that limits the design and the size and the scope of LED displays.
Each LED has a fixed color, red, green, or blue. By grouping these 3 colors together, Toby creates a pixel.
By driving those LEDs at different intensities, making them brighter or dimmer, we can effectively produce any color imaginable.
864 LEDs make up one 14 by 14-inch panel. 23 panels are installed into one halo board cabinet.
So one option is that we could make the cabinets out of steel, but weight is a big factor. And steel is a lot heavier than aluminum. So using an aluminum cabinet saves on weight and saves on shipping costs and saves money overall.
Before the halo board can be shipped to Atlanta, the panels are put through hell.
It's important to test our components that they're going to stand up to those vast temperature changes, rain, snow. We do not want them breaking down at key moments during the big show.
Vibrations caused by the sliding roof could take their toll on the screen.
What we're doing is making sure that that display will be able to withstand the opening and closing of the roof.
Once tested, the 1,848 cabinets that make up the scoreboard need wrapping and packing for the long trip south. Before the team in Atlanta can install the halo board, they must finish the complex retractable roof. Next challenge, figure out how to open and close the roof in a super quick 12 minutes.
We're just gonna go straight up with it.
I get asked a lot, are you really gonna be able to design that? Can they really build something like that?
To keep it simple, the team could make the roof from two large sections that run on long sets of rails. But these roof panels would be heavy and take a long time to roll back. So Erlene's roof will be made up of 8 smaller panels that run along 16 shorter rails. The panels, called petals, are made up of 4 massive steel frames. Each 450-ton petal sits on 2 rails. The inner rail is just like any rail track. Sets of wheels attached to the petal will allow it to roll smoothly on top of the rail. But this won't work for the outer rail. As the petal moves out over the bowl, the back would lift upward as the front tries to tip. So they will position the rear set of wheels underneath the outer rail. This locks the back of the petal into the stadium roof. As the petal slides along the roof, the wheels will roll beneath the outer rail to stop the petal from falling.
Being creative in structural engineering is walking a very fine line. We have to figure out exactly where that fine line is.
Up on the roof, the team lays the rails that will hold the petals.
Good, everything's tied down, ready to go. Very nice.
While down in the bowl,
We don't have a shim on this side.
Avery oversees the construction of the vast retractable roof petals. The petals are too big to be built and lifted onto the roof in one piece. So they're built in 4 sections, a heel that connects to the fixed roof, 2 middle pieces, and the tip that slides out over the bowl. The bowl has become a massive factory, churning out petal sections.
It's relentless. It never stops.
This work site is crammed. As soon as a piece of petal is built, they must hoist it up into position on the roof to make way for the next one.
Good over there? Oh, Lord. Space. There's never enough space. As we built these things, these petals, it's crucial that every lift continues to follow the next one. Otherwise, number one, you can't meet the schedule, and that's what this is all about, the schedule.
Avery must hit his deadline. The stadium must be open in less than 5 months. It's critical that every piece of the roof is precisely the right shape and size.
Oh my God. We're checking every measurement, making sure everything's lined up, because once you go up with it up in the air, you're stuck with it for days while you're trying to get it fit up.
This side's low. need to come down 1/8.
The team gear up to lift one of the largest petal sections into place.
Got to come up 7/16.
And everything's looking pretty good.
With a storm due to blow in tonight, they're keen to get moving fast.
The weather has affected the schedule tremendously on this project. Just 2 weeks ago, we had 4 days of downtime just strictly for rain. When weather comes in, it shuts you down.
A sudden gust could blow the petal off course, causing it to crash into the stadium walls.
There's a storm coming tonight, and you'll have high winds, a lot of rain, so it's imperative that we get everything tied in and safe before we go home for the night.
Adam Castle coordinates the team on the ground.
All right, we're good. Once we pick it up, there's no putting it back down.
Danny Banks provides the eyes and ears up on the roof.
We do need to get it up in place, at least 50% bolted up before the weather does come in. There's an element of danger in everything. You get complacent, go to hang over an edge, slip, whatever the case may be. There's always something. Most of us are pretty well at looking after one another. Yeah, that's the brotherhood of it. Heck, I spend more time with my partner out here than I do at home. So, they're family.
Let's go ahead and start cabling up. Nice and easy. Let it ride off this wood.
It takes America's biggest crawler crane to help Adam's team hoist this roof section into place.
Some of the ironworkers call it the beast. Big boy or Big Red. They call it Big Red. Yeah.
It's probably been called so many names that it's pathetic. But it's been an awesome crane to have on this project.
As the massive frame lifts off, scaffolding is still tying it to the ground. Adam works fast to wrestle it free.
Looking good. We'll let it ride off the end of this.
Two ground crews grapple the structure with ropes to stop it swinging out of control as it rises.
Hey, Gio, let off your side a little bit. Let's try to square this thing up a little more. The pitch looks real nice.
But halfway up,
We're already out of whack.
the tug of war between the ground crews falls out of sync.
You're fighting each other. You're just spinning this thing back and forth. Feed it through nice and easy. You don't have to pull on this thing. All right, hold that right there.
Adam coordinates the two ground crews, bringing them back into sync. The team regain control, and the petal continues its ascent.
Hey, Danny, you up there yet?
On top of the roof, Danny and the ironworkers wait to bolt the petal section into place as the storm approaches.
As you're working in an elevated situation, wind gusts knock you off the iron. It's got its hazards.
Construction workers that are up here, they're almost like mountaineers. They work at heights. They have special training.
Man, it's an adrenaline rush, but ain't nothing that beats it. It's the best thing in the world, man.
It's a dangerous, scary lifestyle, man. But that's what we get paid for.
I don't think I would be a very good iron worker, no.
Your typical everyday iron worker does have a screw loose. So it's all about glory. Cowboys in the sky, right?
a beautiful thing when a plan starts to come together.
Crane driver Andy raises the petal section the last 50 feet.
We look good right there.
Let me know when you're up at elevation there, Danny.
They have to get it above the catwalk, keep it even on both sides, all while walking in. This is where it gets tricky.
The big question, will this massive section of roof fit? If it doesn't, it's back to the drawing board.
We got about another 1.5 feet.
Andy must position the section perfectly so Danny's team can bolt it into place.
All right, we're gonna track you forward again.
Every one of the bolt holes must line up.
We drive pins through the holes to get everything to line up. You need everything to be square, plumb, everything lined up.
Easing down, about another foot. Tell me what you see.
Everybody's in radio communication.
Hold that.
Control of these pedals is critical. You can't let them go. You've got a catastrophe.
At the key moment, just as the team make their final adjustments,
I need slack in that tagline.
Danny's radio goes down.
Can you hear me, Steve? Can you hear me, Dave?
The storm is imminent. They only have one chance to secure the steel, or they must abort the lift.
They're not slacking off. They're just holding it.
Without comms, Danny can't direct the ground crews.
That's got this whole end out, which means it's over. We're see if you can tell them to slack off on that damn.
Can y'all slack off on the east side tagline some more, please?
Fortunately, the Brotherhood of Ironworkers comes to the rescue, helping Danny to regain command.
Can you hear me now? I hear everything.
There's a little bit of a radio malfunction. One of the mics stopped working, but the backup guy took over, and the transition was smooth.
Grab that piece.
Finally, the first bolt is in.
Woo! Hold that.
And Danny can tighten the nuts.
We got 2 diagonal started. We're working on the 3rd one.
After a tense afternoon, this section is secured, and Danny's crew can clear off the roof before the bad weather breaks.
It's attached, it's safe for the storm. If the storm does come in tonight, they don't have to worry about anything.
The ironworkers have another 23 petal sections to install over the next 3 months. As the roof team clock off, another crew clock on down below for the night shift.
Our target is tonight about 850 chairs, maybe 1,000 if we're lucky.
Gino's 14-strong team has been putting in the hours. They must install 71,000 seats. End to end, that's 23 miles of chairs. Each chair needs fitting by hand, but the overhead construction restricts where they can work.
It is the most complex project ever. It's the most cranes I've seen on a job ever in my life, which is causing a lot of delays, I think not on just us, but every trade. This is the first time we've had to really work nights for months on end to finish a project due to a situation on the job site. You got to do it to make it happen.
Yo, let's get these chairs out on the platform. Let's go. It's quick. This is one of the fastest systems in the world. You got to be fit. You got to have good cardio. You need everyone to come and give it what they got.
Adam's human chain can install 40 seats per minute.
We used to carry them up but people's cardio would burn out. There we go. Now I feel it.
The chair's attached to an aluminium beam set into the concrete bowl.
After the beam's all installed, the chair just kind of slides in. This is a unique system because it clips into the beams.
By morning, the crew has installed almost 1,000 seats, which they've had to cover with fire blankets.
There's still an incredible amount of work going up on the roof. There's stuff dropping in, so they're trying to protect them the best they can, so they don't get chipped, broke, stained, melted.
1,000 seats down, 58,000 to go.
We're under a little bit of compression here at the stadium, so it's going to be exhilarating, to say the least.
Everyone is feeling the heat as the countdown to the stadium's grand opening game reaches fever pitch.
Now the hard work begins.
The team building the new Mercedes Benz Stadium has reached the final stage. Over the last 3 months, they've completed the exterior and built the steel frames of the 8 vast retractable roof petals. Inside, the seating is almost finished. Now they can begin to install the world's biggest sports screen. The 60-foot high, 1,100-foot long halo board.
It's amazing how big it is and how much weight it is.
The giant screen was manufactured in South Dakota, made up of 43,000 LED panels, packed into 1,848 cabinets. With the cabinets now on site, the team must bolt them together into 14-foot high blocks.
No let up. We got to go full speed ahead, make our deadline.
Installing the 616 sections of the screen will take great skill.
We have a crew of about 15 guys. So when a section comes to them, they'll grab it, set it in place very carefully, and then they'll bolt them together. And then once they get it all aligned, we'll get it welded in place. On the face of course, you have the LEDs, so they can get damaged very quickly if you're not very careful.
As the 3,500-ton retractable roof closes, the steel holding the halo board will move and flex. The delicate LED cabinets could be crushed together, damaging the screen. So the team has engineered 8 ingenious expansion joints into the halo board structure. As the roof slides and the steel holding the halo board bends, the joints absorb the movement, protecting the vast screen.
So we have one of our 8 expansion joints here, roughly 2.5 inches. When the steel moves, the cabinets will be able to move in tandem with that and not crash into each other. We gotta feel really good once we get this one complete. I don't think I'll ever work on another job like this. This is definitely one of a kind.
This team must bolt 30 screen sections into place each day to stay on track.
They're expecting to see the fans in here real soon. Next thing you know, you'll have grass on the field, I guess.
The team face one final critical challenge before the stadium can open. They must attempt to close the world's most complex retractable roof for the very first time. This is a crucial test. The moment that everybody has been working towards over the past 3 years.
It's a big moment. It's a big moment. Everybody's excited, ready to get this thing closed up.
People ask me, can you really do that? Are you crazy? Can you get this thing to work?
We don't want any mechanical failures. It is very important that this test goes well.
All the petals must roll along their tracks together at the right speed. If any of the petals run at the wrong speed or have been installed at the wrong angle, the frames could collide, jamming the entire system.
Today we're closing the petals for the first time. This move is probably the most important move that will happen in the life of this structure. All 8 petals will move simultaneously. They have to move real close together at all times because at any moment they have to be within a foot or 2 feet of each other or else they'll run into each other. So we have to be very careful.
Andrew commands his 400-strong team to begin closing the roof.
3, 2, go.
96 motors power the wheels on the petals' inner rails, gradually driving the 8 vast steel roof sections. For opening day, the roof mechanization will be computerized. But for this test, they have to go old school.
We have to use tape measures. We don't necessarily know where all the petals are at once. 91 1/4.
91 1/2.
We'll stop at any big pop or bang or anything out of the ordinary, and we'll sound an alarm. 67. We're about 48% now from the closed position, so a little over halfway. 31.
The roof is almost closed. But will the petals meet in the middle?
11. Once those tips all come together, that'll be the closed position and that'll be a success. We don't necessarily know where they're going to line up, so we're going to be watching how close they get and how well they align. 4, 3, 2, 1.
After a tense day, finally, success. The petal tips align. The world's most complex retractable roof is closed. Once the team has clad the petals, the roof should be watertight.
We did it. We are at 100% closed. It's a great feeling. The big step towards getting the stadium open. It changes the entire ambiance of the building. You know, it feels like you're in a different structure altogether. It's pretty cool.
It was awesome. Awesome. A lot of nerve-wracking, you know, but never seen anything like it. When it's the first time something has ever been done, you look back and say, hey, I was a part of it.
Over the next 2 months, the team clads the petals with ultra-tough polymer sheeting. They lay the pitch and add the final touches before opening day.
And that building is going to be exciting to go to for many, many years. You walk into it, and it's not like anything you've ever seen.
After more than 3 years and a whole lot of engineering ingenuity, workers have installed the largest screen in sport.
This job is once in a lifetime.
And built the world's most complex stadium roof to complete the world's most advanced arena.
When I started this project, I never dreamed it was going to be a project of this size. This stadium has overwhelmed me. I'll say that. It's been overwhelming.
The Mercedes Benz Stadium will see many close contests. but nothing that can equal the battle to build this giant.